Hey everyone, my name is Mustafa Mohammed, and I'm a student at the University of Illinois Chicago. I work in the Human and Mind Engineering Research Lab, or HIMER Lab, under Dr. Jeong at the Department of Mechanical and Industrial Engineering. And so this video is going to be an overview of my work, which was presented at the 2021 Human-Robot Interaction Conference, and is titled Human-Robot Collision Avoidance Scheme for Industrial Settings Based on Injury Classification. So I think it's important to mention first that just over the last 3 years, there have been over 2 million collaborative robots that have been installed in factories across the world. And these collaborative robots, which are also known as cobots, are really effective at preventing injuries that are associated with repetitive movements. Before they're used, it will be very common for workers to have to take long periods of time off from work because of injuries to their back or knees from lifting or moving heavy objects repeatedly. And installing these robots has taken these risks away from factory workers. However, these robots have to be in close proximity to their operators in many situations, in which what is called a shared workspace. And these shared workspaces allow for very effective manufacturing with the precision of robots, as well as the versatility that only humans can have. However, the potential for injuries is very high, as heavier or faster robots can be just as hazardous as slower and lighter ones with a sharper payload. So the task at hand is to figure out how to make these environments safer. And there have been a lot of attempts in the past to do so. For example, sensors that measure physical data have been implemented quite frequently, and many of these are based on electrostatic capacitance, torque, or even humidity detection, for example. However, the problems that come up with all of these is that firstly, they're extremely costly, for the primary reason that they're directly installed on the robot. And secondly, it was found that physical sensors such as these end up causing more opportunities for mechanical latency in the slowing down or stoppage of the robot. And because of this, it opens up the possibility of more injuries being caused. So for this reason, I'm focusing on computer vision to solve this problem, because using virtual sensors provides an opportunity to have this latency be reduced, therefore limiting the number of injuries caused by these robots. And so the system I developed is one that takes advantage of 3D computer vision to create depth maps of a shared workspace. And the benefit this can give me is that it will allow me to accurately track the movements of operators and robots in the environment. And 3D vision was chosen over 2D vision primarily because this system is meant for use in indoor environments. And therefore, one of the challenges that needs to be bypassed is the poor lighting and reflectivity of many areas. With 2D vision, this would be very burdensome, and it would result in unsafe environments. On the other hand, 3D vision can see through suboptimal conditions, and it would also allow for the position of every object to be known, which is better than using an imperfect 2D stereo vision method, for example. And one of the main points to keep in mind for this application is that the problem that's being solved, at its most basic level, it's just a perception problem. So the system that's developed, it really has to rely on the understanding of where the humans and robots are in the scene. And it's also important to take into account that the robot might not be able to instantaneously stop, and that humans will be moving while the robot is in the process of stopping. And it needs to identify the orientation of the robot in relation to the human, the different places the robot can reach, as well as the position of humans and where they could possibly move. So in the environment, there's an Azure Kinect time-of-flight camera at a peripheral bird's eye view. And what this will be doing is, in real time, it'll be collecting point clouds, which are just representations of X, Y, and Z coordinates. And with this data, machine learning algorithms are used for identifying which object is in the environment with classification, as well as where the objects are moving with detection. And from the depth maps, the distance and subsequently the velocity will be generated in real time by taking the difference in position from select objects. And the object detection algorithm will be creating bounding boxes that surround the objects in 3D. And from this, the shortest distance between the boxes will be monitored. And furthermore, this can be extended out to tracking the velocities of objects, where it can be input to generate the predicted impact force of the collision, because it should be done with safety in mind. And finally, from there, I can use this result to classify how severe the potential injury might be. And based on this, I plan on sending the information to workers through a head-up display, which would allow them to move accordingly based on how risky it is for them to be in a certain position or move in a certain direction. And although the work isn't fully finished, I'm confident that it can help us take steps to the development of a safer entry risk warning system for collaborative robots. Thank you for watching, and feel free to contact me if you have any questions.